Greetings and welcome, G-Amigos. Mr. Waddy here. We're talking about the geometria. This is going to be delicious, not unlike a lot of things. But let's see, question 8, it says, find the value of x that makes the lines parallel, right? So if I want these lines to be parallel, these angles would need to be congruent, because these are what kind of angles, friends? Internet friends, my entire class just simultaneously said in unison, in a chorus, they said alternate interior angles. And so if I could use the alternate interior angles converse, I could prove the parallel line, or prove the lines parallel, demonstrate their parallelity, right? Whenever those two things are congruent, thereby their angle measures being equal. So 3x, when 3x equals 2x plus 20, those two things will be congruent. Subtract 2x from both sides, I would get x equals 20. And I'm donezo. So when x is 20, then the lines are parallel. Right? Right? All right, G-Amigos, let's keep cruising. This is a speed run after all. Ooh! So I love this. These problems are my favorite. So if I want to prove, say, m is parallel to n, could I, for question 13? I can prove that these lines are parallel. If I know that these angles are congruent, I could do so by the alternate interior angles converse. Converses are used to prove parallel lines. The theorem version starts with the lines being parallel and would conclude something about the angles being true. How about question 15? What kind of angles are those ones? They're alternate, but, well, one's an exterior, one's an interior. They're not corresponding. They're kind of, guess what, friends? The answer to this one is no. You heard me. There's nothing special about those angles. There is an instance in which those two angles could result in those lines being parallel, and that instance would require them to be right angles, because if this is 90, then this is 90, and then corresponding angles converse. So check this out. I've got a little doodle for you right here. Here's that same sketch, internet friends, right? And watch this. Those are those angles. And if I change these measurements, here we go. Notice those angles stay congruent, but those lines are not parallel. Oh man, internet friends, you should see the audience right now. They're like crisscrossing their arms like these lines that aren't parallel. What dance move is that? What do you call that one? If I was a Fortnite character and was dancing with my arms moving like this, what would it be called? Okay. Internet friends, my students just dropped the phrase Skull Trooper. Hopefully that's not an inappropriate thing, but comment below if that's your favorite Fortnite character or weapon or skin. There you go. So that one's a no-go. How about question 17? Those are vertical angles, but I already knew they were congruent. But those are vertical angles. Can I prove any lines parallel? I've got like 4 lines. Surely some or both pairs need to be parallel, right? Here, gentlemen, please. The answer is no again. What? Watch this. Let me click on this little drawing I made. So here's a similar sketch. Those angles are vertical angles, but I already knew they were congruent, right? I'm not saying they aren't congruent. I'm just saying that these lines are not necessarily parallel. Look at that. Look at that. That's like a beautiful butterfly turning into a diamond. I don't know. Like that? You like that? So yeah, those lines are not necessarily parallel. Okay, so that's a no-go. Don't worry, we're still cruising. All right, check this out. Here we go. If this is 65 and this is 65, I think I could say, man. All right, I could say these ones were parallel, but I don't have a name for them. Well, either way, the green lines are parallel by corresponding angles converse, but they specifically wanted to know if AC and DF were parallel. Well, let's see what I can do, friends. So this one's a hundo 15 degrees. If that's 115, linear pair, what's this angle going to be? Well, it is, in fact, going to be 65 degrees right there. And if that's 65 and this is 65, with respect of the two lines in question, Ode, sir, please. What kind of angles are those? Those two purple ones I've just highlighted. No, those aren't angles, though. What kind of angles? What's the relationship? Corresponding angles. So I could say that these two angles are corresponding, and by the corresponding angles converse, I could now conclude that those purple lines are parallel. All right, keep carousing, friends. Ooh. There will be, by the way, internet friends and friends in real life and G-amigos all over the world, there will be a question like this one on the test coming up Tuesday or Wednesday. This information will be old by the time it's past that date. So here you go. Let's write a proof together. Here we go. Mr. O, sir, are you writing this down for the sake of your learning? Yeah, let's do that. You're talking a lot to your G-amigo there, and you're harming each other. It's not great. So let's see. Given A is parallel to B. Given. All right, so I know A and B are parallel. Actually, tell you what. Let's highlight those whole lines. How about? So I presently know those lines are parallel. Okay? I also know angle 2 is congruent to angle 3. Why? Given. That's a letter 6 is what you call that one. That's not a G. You like that? I call the number a letter. Pretty funny. It's what the fans like. The fans like it when I say the thing the wrong way. It's weird. So angle 2 and 3 are congruent. All right, so we don't have a name for those kind of angles. Later on in Chapter 7, we'll call those opposite angles in a parallelogram, but they are not related with respect to lines, transversals, things like that. So what's something else I could say that's true about this picture? Okay, now this is a classic setup. Angle 1 and 2 are corresponding. I don't yet know they're congruent. All right? Because they are corresponding with respect to these two lines, which I don't yet know are parallel. That's what I'm trying to prove. So I can't actually use corresponding angles theorem to say 1 and 2 are congruent until I know those lines are parallel. Question, comment. Congruent is when it's the same shape and the same size. Right? So two congruent squares would be exactly the same size square. Right? Same. So I can't make a jump from 1 to 2 yet because I don't know those lines are parallel, right? Yoshi, Odie, right? You guys with me? Here, track with me here. This is good. This is fresh stuff. So here, angle 2 and angle 4. What kind of angles are those, though? Nope. They are interior. Are they on the same side or different sides? They're consecutive interior. So according to the consecutive interior angles theorem, because I know that these lines are parallel, what would I know is true about angle 1, 2, and 4? Yeah, they add up to 180, or they are supplementary. Right? Right. Yeah. All right. What else? What else do I got here? That help me? I don't know. Oh, can I say something about 1 and 3? I think those are congruent. Alternate interior angles theorem. I like it. Well done. And I can say that because once again, they are dependent on those two lines, A and B being parallel. I do know that at this moment. Okay. Ooh. Angle 1 is congruent to angle 2. I don't think I even needed angle 4. Right? Angle 1 is congruent to angle 2, which is what someone said earlier. They were right. It's true. They just didn't know why it was true. We'll check this out. If I combine this and this, I know that if 1 is congruent to 3 and 3 is congruent to 2, therefore 1 is congruent to 2 by transitive or substitution. Either one works. Now, if I know that 1 and 2 are congruent, someone pointed out those are corresponding angles with respect to lines C and D. I think we're there, friends. I think we're there. I used green. I'll use red, I guess. I think I have enough information to say C is parallel to D. How can I say that based off of this information? So using the fact that 1 is congruent to 2. Oh. What kind of angles were those again? Corresponding angles. The corresponding angles theorem says something true about angles. Corresponding angles converse proves lines parallel. Which one do I want? Converse. That's right. Because I'm making a statement about lines being parallel. So notice this, my friends. I ended up, I said this was true. It was true. And I'll sometimes write this on a test. This was true, but not helpful. Right? Which sometimes is a pretty good filter of when you say something mean to someone. Maybe it's true, but was it helpful, friends? Right? Like if you said, for instance, your avocado's not ripe anymore. Right? Like they'd all be like, that wasn't nice. True, though. Hey, it's true. Sometimes Mr. Waddy's a straight shooter. What can I say? Well, thanks for being here, internet friends. Hope you all have a great day. Adios. Go have some guacamole.